This is an IIPMT 2015 question from System of Particles. The problem is like this. An automobile moves on a road with a speed of 54 km per hour. Let us take down the data. Speed is 54 km per hour. By multiplying with 5 by 18, we can convert that into meter per second. 18 threes are 54. So initial speed is 15 meter per second. Speed is 15 meter per second. The radius of that wheel is 0.45 meters. Moment of inertia of that wheel is 3 kilogram meters square. The vehicle is brought to rest. That means its final velocity equal to 0, either linear velocity or angular velocity. And in a time of 15 seconds, final velocity is equal to 0. Final velocity is 0. Then what is an average torque? So what the thing that I want to find out is torque. Another formula for the torque is I alpha, where I is already given for you. Moment of inertia is of the system is 3 kilogram meter square. So if I have to solve the problem, I need to know alpha. As I know V and R, I can use a relation U or V. I can call V equal to R omega or omega initial, where I can say omega final equal to 0. So using that, V is 15, R is 0.45 and omega I. Using that formula, V equal to R omega, as V is 54 converted into meter per second is 15. Radius is given as 0.45. I'll assume that as an initial angular velocity. So initial angular velocity is 15 by 0.45. That is 15 by 0.45 means 45 by 100. That 100 come to the top. So 5 threes and 5 nines. 3 threes. So initial angular velocity is 100 by 3 radian per second. It is given that in a time of 15 seconds, it came to rest. That means its final angular velocity is also equal to 0. So similar to V equal to U plus AT formula, I can write final angular velocity is initial angular velocity plus angular acceleration to time. Final angular velocity is 0. Initial angular acceleration we have calculated as 100 by 3. Alpha we don't know in a time of 15 seconds. So alpha equal to minus 100 by 3 into 15. We can further simplify this. 5 threes and 5 20s. That is minus 20 by 9 radian per second square. Negative angular acceleration tells you that the body is going to come to rest. Once you got alpha, I can use a formula. As I said, tau equal to I alpha. I is 3, alpha is 20 by 9 in magnitude. So that is 20 by 3. 20 by 3 is 6.66. Torque is I alpha. Moment of inertia is kilogram meter square mr square. And unit is second power minus 2 when you simplify that, right? So you got this answer. This is how we solve the problem. So be careful that you want torque. So I alpha, I is given, you don't need alpha. To get alpha, I had first calculated initial angular velocity. As it came to rest, final angular velocity equal to 0. And I used a formula, final angular omega f equal to omega I plus alpha t. From that, I have calculated the torque alpha, and then I have substituted here to get that answer. So it is that's how we have to proceed and try to understand and solve the problem. Thank you for watching.